So moving forward, something that we can quickly do when we're working with Python, especially with pandas, is reshape our data or derive it from other columns, right? So this is pretty common in Excel. We can create this revenue per age column. If you're here in Google Spreadsheets, you're gonna do something like revenue per age, and you're gonna do something like equals, right? Equals revenue divided, I don't remember if this is the correct formula we were using, but just for you to have a reference. And we're gonna pretty much extend this whole thing. There you go. Oh, well, it's processing. I have 100,000 rows, so you can see how slow it is. And let's compare that just to the way Python works. I'm gonna execute this thing. It was instant, extremely fast. And it was all calculated. Seems that we have the same results as expected. And we can quickly plot both in a density plot and in a histogram, as you can see right there. Not that revenue per age is gonna be relevant in any case. It's just to show you the capabilities of what we can do. Let's analyze. We're gonna create a new column, which is calculated cost. And it's the total orders, the quantity of the order times the cost, right? Extremely simple formula, very fast to process, and we're gonna get right here how many rows had a different value than what was provided by cost. So what we're doing right here is like we're quickly checking if the cost provided by the data set at some point doesn't align with the actual cost we are calculating. So is there any mistakes that were made by the original system or people doing data entry? If this new column is different from cost, we want to know about that, and that doesn't happen. So again, quick regression plot. In this case, it's very obvious that there is some linear dependency between calculated cost and profit. So more formulas, in this case, cost plus profit. So we're gonna adding a little bit more. There is no difference with revenue and the calculated revenue that we are having, so that all makes sense. We're gonna do a quick histogram of the revenue. We can, for example, add 3% to all the prices that we are using. We need to increase prices. How are you gonna do that? Well, it's very simple with Python. We're just gonna do increase everything by 0.03, and now all the prices have changed. What else? We're gonna be able to do quick filtering. Let's get all the sales from the state of Kentucky, right? So these are all the sales from the state of Kentucky. We can get only the average of the sales by these age group on only revenue, right? So all these filtering options are extremely simple to get with Python. In this case, we say, give me all the sales from this age group and also from this country, right? And we're gonna get the average revenue from this group that we are selecting. And again, to modify the data, we can make just a few quick modifications. Like in this case, we're gonna say all the sales from country, right? The revenue, we're gonna increase it by 1.1. I don't know why, we're just doing it arbitrarily. It's just for me to show you how it works. So far, so good. Again, we've done a couple of things. You don't need to know about the details. We will actually go through that in the NumPy and the Pandas sections in this tutorial. So just for you to have a quick reference of it. There are exercises associated with this given lecture. So if you wanna pause right now and get into the exercises, that's gonna be very helpful. We're gonna move forward now with the second lecture, in which we will be using a database, this Aquila database, and we're gonna be reading data instead of from a CSV file, as we did before. We're gonna read data now from a database. reading data from a SQL database is as simple as it is from an Excel file or a CSV file, as we were doing with our previous example. And once you've read the data, as we're going to do now, the process is the same. So what we have right here is a query, a SQL query. If you don't know about SQL, you can check our courses or other courses online. Basically, we're pulling the data from the database. This is one of the advantages of Python. It's that there are connectors for pretty much every database provided out there. Oracle, Postgres, MySQL, SQL Server, etc. In this particular example, we're going to be using MySQL. So once you construct the query and you pull the data from the database, then the process is the same. We have just converted this outside data into a data frame that we can use with our Python skills. The first step, as usual, is to check the shape, information, description of our data frame. In this case, we want to again understand the structure of it. So we want to know how many rows we have, 16,000. We want to know a little bit more about our rows. We want to know about a little bit more about our columns and how many rows, how many records we have for each one of them, and the type of each one of these columns. And we also want to have a better statistical understanding of our data. So we do a quick describe and we have more details about it. If we want to focus in individual columns, right, we can just do that by, in this case, we're going to focus in film rental rate, right? Pretty much how much you pay to rent a film. And we're going to see the kind of distribution we have. We can call it a distribution. It's pretty much a categorical field in this case, but basically the rentals are divided in three main categories or prices: $0.99, $2.99, and $4.99. So that's this box plot, this pretty much perfect, never seen in real life box plot gives you those prices. And moving forward, we can also check very quickly a categorical analysis, understanding the distribution of rentals between cities. So we have two cities and it's pretty much even, as you can see right here. Creating new columns and reshaping the data for further analysis, etc., is relatively simple. In this case, we're going to analyze the return in rentals, right? Which films are going to be more profitable for the company. Dividing the rental rate, how much we charge, divided by the cost, how much it costs us to acquire the film. So in this case, we can see the distribution of that, right? So most rentals are here in the beginning, and then we have more profitable rentals. We're making up to 60% above the rental, and we can quickly analyze the mean and the median of it, right? So to have a quick idea of all that. Finally, selection and indexing. If you want to start focusing, if you want to go in the data, right? You want to zoom in, you want to have a better understanding, so you start filtering. In this case, we can filter by customer, but if you want to do it per city, if you want to do it per state, if you want to do it per film, per price category, etc., it's very simple to filter and zoom in just one particular characteristic of your data, so you can perform a more detailed analysis. So in this case, we have all the films that were rented by the customer, last name Hansen, which doesn't mean it's the same person. But again, it's very simple to filter that. And here we can very quickly see which ones are the films that have the highest replacement cost, right? So basically what we're doing is we're gonna isolate those films that have the highest replacement cost. And also we can see right here, just for you to have an idea, all the films that are in the category PG or PG-13. It's very simple also to filter that data. So this is the process we usually follow. We import the data, we reshape it somehow, create columns. There is an important process of cleaning that we're not highlighting in this part of the tutorial. We're going to talk about it in the tutorial itself. There's the process of cleaning, then reshaping, creating new columns, combining data, and creating visualizations. This is the process, right, that we're following here with our Python skills. There is a ton more to add, as you might imagine, from creating reports to running machine learning processes, creating linear regressions, etc. For now, this is just a quick understanding of the process we follow. And now, starting now, we're gonna move forward with more details of each one of the individual tools. We're gonna talk about Jupyter Notebooks. We're gonna talk about NumPy, we're going to talk about Pandas, we're going to talk about Matplotlib, Seaborn, etc. Starting now, right? The first thing you're going to see is what is this whole thing that I've been using, this Jupyter Notebook. I want you now to, if you don't have experience with it, I want you to have an idea of how it works, and then we're going to move forward with the individual tools, NumPy, Pandas, etc. Remember, there are exercises also associated with this particular lecture, so you can always go back again and work with them once you get a better understanding of the tools we are using.